Professor Roger Penrose article about singularities in the center of the black holes is highly questionable because NASA has measured back in 2014 that universal space has Euclidean shape. Now thinking that universal space has some real physical curvature that is curved might be it is only a mathematical description of something more fundamental. If we are in intergalactic space, we can imagine that the energy density of space there is a Planck energy density. Okay. And we know in physics that every system has a tendency for the homogeneous distribution of the energy. So now you imagine that I put this clock in the intergalactic space. I put this clock in the space. So what will happen there? It will happen that the energy density of space, which we call today superfluid quantum vacuum, will diminish in the center of this clock exactly for the energy of the clock. Okay? That means energy density in the center of this clock is Planck energy density minus mass of the clock by c squared divided by the volume of the clock. Okay. If we rearrange a little bit this formula, we will get formula energy of this clock is mc squared, and this is equal to the Planck energy density minus energy density of space in the center of the clock by volume of the clock. And this is extension of the mass energy equivalence principle on the universal space. So in the universal space where a physical object exists, energy density of space is lower exactly for the amount of the energy of the space, of the physical object. Now, when we go in the black hole, in the black hole, the energy density of space in the black hole is lower. And in the center of the black hole, energy density in the center of the black hole is exactly the same principle is valid as for this clock. Is energy density of Planck minus mass of the black hole by c squared divided by volume. Okay. And because mass of the black hole, we know it's very huge, and the volume is small. Let's say the black holes are very squeezed. Our sun, to become a black hole, would have a radius of 3 kilometers, but the same mass. So the energy density in the center of the black holes is very low. And I believe that this low energy density actually is a real physical property in the center of the black hole. That Professor Penrose has described with the high curvature. With the high curvature. So this high curvature of Professor Penrose actually is a mathematical description of the physical property that universal space in the center of the black hole has extreme low energy density. But there is no singularity there. These mathematical singularities are only the let's say, the pointing towards physical circumstances that are really special. And this is this extreme low energy density. And because of this extreme low energy density of space in the center of the black holes, atoms there become unstable. Atoms are falling apart into elementary particles, and in the center of the supermassive black holes, there is immense pressure because of this, and these huge jets are formed. So we published an article about this, and you can read this article on the file attached below. I wish you a good day.